Hey there, I'm Brett, and today we are diving into systems of equations. Today's lesson is part 1 of a 3-part series on systems of equations. So make sure that you subscribe to the channel to get access to all 3 parts of this series. And without further ado, let's jump into part 1, an introduction to systems of equations and the graphing method. So soon enough, you're going to learn how to solve these problems algebraically using the substitution or elimination method. But before we learn that, I think it's really nice to just begin with the most basic form of solving these problems, which is through graphing. So a system of equation simply means that we have multiple equations and we want to find the coordinate point where they intersect. It seems that if we want to find where they intersect, we could just graph both lines on a coordinate axis and read off their intersection point, and that is what we're going to do today. So, as I've talked about before, the easiest way to graph a linear equation is from slope-intercept form. So it looks like this second equation here is already in slope-intercept form, but the first one isn't. So I'm going to go ahead and subtract x over so that I have y isolated. Now I can simply go ahead and plot both of these lines on a coordinate axis. So I'll plot this line first. And next let's plot this line. Our answer is the place where the 2 lines intersect, and if our equations are nice to us, that will be on a whole number interval, which it is in this problem, so it looks like it's at the point 1, 0. So that's our solution to this problem. So in our next problem here, we have 4x minus 3y equals 18, and y equals -2, and we want to find where these 2 points intersect. Of course, if we knew the substitution method, this would be a great candidate for it, but right now we're doing it longhand so we can see visually what is going on. So what I need to do here is just solve for y in our first equation to get it into slope-intercept form, and then I will graph both of these lines on the same coordinate plane like I did before, and we will read off where they intersect. So to plot this line, I'll mark it on the y-axis at -6 and give it a slope of 4/3. The other line we need to graph is y equals -2. What this means is that we have a line where every single point has a y value of -2. So what I'm going to do is I'm going to go to the y-axis, find where -2 is, so 1, 2 down, and then every point that has that as a y coordinate is on this line. So basically it's going to be all of these points. So what we get here is a horizontal line, and you can just remember that anytime you have y equals a constant, it creates a horizontal line. And our intersection point is right here, and that is the point 1, 2, 3 on the x-axis and down -2 on the y. The last thing I want to talk to you about is some special cases you might run into when solving systems of equations. And you can't tell yet, but number 3 is going to be one of those special cases. So we're going to start just like we've started all the problems before and rewrite both of these equations in slope-intercept form. So what you might notice now is that both of these lines have slopes of +4. And that implies that these lines are parallel, because remember how parallel lines always have identical slopes because they are traveling in the exact same direction. And if they're traveling in the exact same direction, they never cross. So there is no intersection point here. I could graph these, but you would see that they're just two parallel lines, one crossing the y-axis at -2, the other crossing the y-axis at +3, and they never intersect. So when you come across this situation, you can immediately say that there is no solution. Once again, I'm going to begin by taking both equations and rewriting them each in slope-intercept form. After changing both of these equations into slope-intercept form, we see something very interesting. We see that they both reduce down to the exact same equation. We have y equals 1/2 x minus 2. So what this means is that I have this line, y equals 1/2 x minus 2, graphed, and graphed on top of it is the exact same line. So what this means for our systems of equations is that the solution is every single point on those lines, because one line is graphed on top of the other. And how you say this in words is that you say it has infinitely many solutions. Now that you have a grasp for what systems of equations are and what they mean on a graph, you are ready to solve them algebraically. On the next episode of Math Hacks, we are going to be looking at how to solve systems of equations using the substitution method. So make sure to subscribe to the channel and follow me on social media to stay up to date. Till next time, I'm Brett, and thank you for joining me.